today's question is exercise 5.1 continuity, question number 10 from ncert. Find all points of discontinuity of f where f is defined by f of x is equals to x plus 1 if x greater than or equals to 1, x square plus 1 if x less than 1. Now we are going to find the points of discontinuity of f. So before going to discontinuity, first we check the continuity for different values of x. So we check continuity. For different values of x, they are what they gave here: x greater than or equals to 1, x less than 1. So here we have two cases. One is greater than 1, one more case is x equals to 1. So I will write separately that cases. First one, when x is equals to 1, and second case, when x greater than 1, and third case, when x less than 1. So for these three cases, we will check continuity for this function. Case 1. So case 1 is at x equals to 1. So at x equals to 1, the formula is, I told already, when it is equals to 1, we will write left hand limit is equals to right hand limit is equals to f of 1. So we will use this formula. LHL, left hand limit of 1. How can we write left hand limit for this 1? Means limit x tends to 1. Left side of 1 is less of 1, means 1 minus. I will indicate with this 1 minus f of x. Now I will use here 0, means I will start from 0. H tends to 0. F of this x is replaced by 1 minus the new variable h, 1 minus h, f of 1 minus h. Now we will write the function. When 1 minus means less of 1 value, below 1 value, means less than of 1. When x is less than 1, what is the case? So here we got the case. When x is less than 1, at the time the function is x square plus 1. So here I got x square. Here in the x place what we have? 1 minus h. So I will write 1 minus h. X square, x over, x is 1 minus h over plus 1. So x square plus 1 completed. Now write the h value in this function. So h is 0. Right here 1 minus 0 whole square plus 1. That equals to 1 plus 1. That equals to 2. So LHL value I got 2. Now let us take RHL. Suppose I am taking RHL is equals to, what is RHL? Right hand limit of 1. Means right side values are more. Means 1 plus I will use. Limit x tends to 1 plus f of x. So this is that formula. In this, I want to start from 0. I replace this value. H tends to 0. F of x is replaced by 1 plus h, 1 plus h. Now what is the function when 1 is more than 1? When 1 is more means 1 plus is x is greater than 1. The case we will check where we get x is greater than 1. Check the condition. So it is x is more than 1. At that time the function is x plus 1. Write this function here, x plus 1. What is x here? 1 plus h. So 1 plus h plus 1. This is the function. Now write h value in this. H tends to 0 and 1 plus 0 plus 1. Now sorry, I substituted value, no need to write. Here I substituted, then remove limit. Next 1 plus 1, 2. LHL is 2, RHL is 2. Next here we did LHL, we got 2. RHL also we did, we got 2. Now we want to do f of 1. The next case, f of 1 case. For f of 1, what is the value? We will check. F of 1 equals 2 means x is, check the function. Here the x is equals to 1. At that time the function is x plus 1. So take x plus 1. Here what is the x value? 1. So in the x place you write 1 plus 1. So f of 1 is 2. Now we got LHL2 or HL2 f of 1 also 2. Therefore LHL is equals to RHL is equals to f of 2. F is continuous. Why? Because all are equal. Then f is continuous. Next, second case. Go for the second case. What is the second case? When x greater than 1. So when x greater than 1, that is the case 2. Go for case 2. Case 2 is case 2, x greater than 1. So this is the case 2. When x greater than 1, what is the function? So the function is x plus 1. So write this function. F of x is equals to x plus 1. It is polynomial function. This is polynomial function. Therefore f is polynomial function. Then f is continuous. Next, last case. What is the last case? Case 3 is x less than 1. So at x less than 1, the function is x square plus 1. It is polynomial. This is polynomial function. So this is polynomial function. Therefore f is continuous. And we will give final conclusion. How can we write the final conclusion? Means we check all the cases. Case 1, at case 1 it is continuous. Case 2, it is continuous. Case 3, also continuous. Means for all real numbers, f is continuous. The final conclusion is, we'll give the final conclusion. Therefore, f is continuous for all x belongs to R. So, for all real numbers, this function is continuous. There is no discontinuity point in this question. Next, we go for the next question. Question number 11. So, question number 11. Question number 11 is, find the discontinuity points for the function f. F is defined by f of x is equals to x cube minus 3 if x less than or equals to 2, then x square plus 1 comma if x greater than 2. So for this function we need to check continuity. If it is not continuous, then that point is discontinuous point. So first we check continuity. We check continuity for different values of x. What are the different values of x here we check? One is x is equals to 2, one case. One more is x less than 2, another case. And next is x greater than 2. Total 3 cases are there. This first case is x is equals to 2. Second case, x less than 2. Third case, x greater than 2. So for these 3 cases, we are going to check the continuity of this function. So first I will use at x is equals to case 1. Case 1 is at x is equals to 2. So at x is equals to 2, how can we write this one? LHL is equals to RHL is equals to f of 2. Now LHL, how can we write LHL? Left hand limit for 2. Left hand side of number is 2 minus. So I will write limit x tends to 2 minus f of x. Now I want to replace this 2 minus by 0. So how can we write? We start from 0. So I will write limit h tends to 0 f of 2 minus h. So 2 minus means less than of 2. What is that function? When function is less than 2, the function is x cube minus 3. So x cube, what is x here? 2 minus h whole cube. X cube minus 3. So it is minus 3. Write h value in this. So 2 cube minus 3. 8 minus 3, 5. So it is LHL. Next, RHL. We need to check RHL. How can we write this RHL of 2? Limit x tends to 2 plus f of x. Now I want to start from 0. I will start from 0. limit h tends to 0, f of 2 plus h. This is f of 2 plus h, means more than 2. When x is more than 2, see, this is more than 2, x is more than 2. At that time, the function is x square plus 1. So, write this one, limit h tends to 0. The function is x square, x means what? 2 plus h whole square, x square plus 1. Now, write h value in this function, 2 square plus 1, that is 5. RHL also 5. Here LHL is 5 and RHL is also 5. And next go for the f of 2. Right? F of 2 means when x is equals to 2, what is the function? We'll check here. When x is equals to 2, the function is x cube minus 3. So, x cube, what is x here? 2. 2 cube minus 3. 8 minus 3. That is 5. So, if we observe, we get all conditions are equal. Means LHL is 5, RHL is 5 and f of 2 is also 5. So, 3 are equal. LHL is equals to RHL is equals to f of 2. Therefore, f is continuous. F is continuous at x is equals to 2 case. Next, case 2. Case 2 is x less than 2. X less than 2. So, when x is less than 2, what is the function? Just check the question. In the question, when x is less than 2, the function is x cube minus 3. So, write this function. F of x is equals to x cube minus 3. Is it polynomial or not? Yes, it is polynomial function. This is polynomial function. Therefore, f is continuous. F is continuous. Next, case 3. The last case in this. Case 3. What is the case 3? At x greater than 2. So, when x is greater than 2, the function is x square plus 1. See, it is greater than 2, then function is x square plus 1. So, we will write here f of x is equals to x square plus 1. This is polynomial function. This is polynomial function. Therefore, f is continuous. Now tell me, what is the final conclusion for this question? If you observe 3 cases, the first case x equal to 2. At this case, f is continuous. And case 2, that is x less than 2. X less than 2 also continuous. And the third case, x greater than 2 also continuous. So, we will give the final conclusion. Thus, f is continuous for all real numbers. F is continuous for all x belongs to R. So, this is the solution for 11th question. Next, go for the 12th question. The 12th question is, find the discontinuity of the function. We need to find the discontinuity of the function. F is defined by, they gave the function is f of x is equals to x power 10 minus 1 if x less than or equals to 1. Next, x square if x greater than 1. So for this function, we will check continuity for different values of x. What are the different values they gave here? One is x is equals to 1, one case, x less than 1, another case, and here x greater than 1, one more case. So here we have 3 different cases. For these 3 different cases, we will check continuity. First, I will write 3 different cases. Case 1, when x is equals to 1, that is the case 1. Case 2, x less than 1. Case 3, x greater than 1. So for these 3 cases, we will check continuity. First case, I will take the first case. Case 1. Case 1 is when x is equals to 1. How can you write this when x equals to 1? That is LHL is equals to RHL is equals to f of 1. So how we write LHL of 1? 1 LHL is 1 minus, means less values of 1, that is 1 minus. So I will write LHL is equals to limit x tends to 1 minus. Why? Because it is LHL of 1. So 1 minus into f of x. Now I will start from 0. H tends to 0, f of 1 minus h. Now what is the function? When x is less than of 1. 1 minus means less than of 1. When x is less than of 1, see, check the question. When it is less than of 1, the function is x power 10 minus 1. So the function is here x power 10. What is x? Here x is 1 minus h. So I will write 1 minus h whole power 10 minus 1. Just I replaced x by 1 minus h in the function. Now write h value in the function. H value is 0. Write 0 here. What do you get? 1 minus 0 whole power 10 minus 1. Means 1 power 10 value. How much? 1 minus 0, 1. And 1 power 10 minus 1. What is the 1 power 10 value? 1 minus 1, that equals to 0. So here I got LHL value 0. Now I want to find the RHL. I want to find next RHL value. So what is RHL? Right hand value of 1. Write RHL limit x tends to right hand value of 2. Right hand value of 1. What is the right hand value of 1? 1 plus. So it is right hand value into f of x. Now I want to start from 0. Then limit h tends to 0 f of 1 plus h. I want to replace x by 1 plus h. Now write the function. When the function is more than 1. 1 plus means more than 1. So when it is more than 1, the function is x square. X is greater than 1, the function is x square. Write here the function x square. But what is x here? Here x is 1 plus h. Write 1 plus h whole square. So now write here h value. What is the h value? 0. 1 plus 0 whole square. That is 1 square. 1 square means 1. Before we got LHL value is how much? 0. But here RHL value 1. Is it equal? Both are equal? No. Both are not equals. LHL not equals to RHL. Next, case 2. Case 2 is case 2 is at x less than 1 case. Case 2 is x less than 1. When x is less than 1, what is the function? X power 10 minus 1. So f of x is equals to x is less than 1 at that time. The function is x power 10 minus 1. So this is polynomial function. This is polynomial function. Polynomial function means it is continuous. Therefore, f is continuous at x less than 1. Next, third case, the last case. Third case is when x greater than 1. X is greater than 1. What is the function? Function is x square. So, f of x is equals to x square. This is also polynomial function. This is polynomial function. This is polynomial function. Therefore, f is continuous. Continuous. Now give me final conclusion. If you observe at case 1, it fails. It is not continuous. It is discontinuity. At case 1, at x is equal to 1, the function is discontinuous. Next, at case 2, it is continuous. And case 3 also continuous. How can we write the conclusion? Means f is continuous. Write the conclusion finally. Therefore, f is continuous for all x belongs to R except 1. At except 1, it is continuous. But at 1, it is not continuous. It is discontinuous. Next question. I hope you are understanding this. If you have any doubts, please comment. Okay, I will start next question. Question number 13. The question number 13 is the function defined by f of x is equals to x plus 5 if x less than or equals to 1, x minus 5 if x greater than 1. A continuous function. They are asking, is it a continuous function or not? They are asking. Continuous function. So for this, first we write the different values of x. So we check continuity for different values of x. For case 1, what is the case 1? Here we have x less than or equals to 1, means two cases. One is x less than 1 case, one more case is x is equals to case. Suppose I am taking the first one when x is equals to 1, the first case, and second case when x less than 1. X less than 1. Next, third case, what is this? X greater than 1. Third case is when x greater than 1 case. Now we will start the first case 1. So case 1, what is the case 1? When x is equals to 1. So when x is equals to 1, how can we write this? LHL is equals to RHL is equals to f of 1. Now, how we write the LHL of 1? LHL is equals to limit x tends to 1 minus left hand value into f of x. So, I want to start from 0. Then I will begin with 0. H tends to 0, f of 1 minus h. Now 1 minus, when the function is less than of 1. Less than of 1 is function is x plus y. Write this function. So x plus 5. Here what is x? 1 minus h. 1 minus h plus 5. So next, now write the h value here. 0. 1 minus 0 plus 5. That is 6. Next, RHL. What is RHL? How can we write this RHL? Right hand limit is equals to limit x tends to right hand of 1 means more than 1. 1 plus f of x that equals to, I'll start from 0. So limit h tends to 0 f of 1 plus h means here the value 1 plus means more than 1. Check the question. So more than 1. When it is more than 1, the function is x minus 5. Now write this function x minus 5. What is x here? 1 plus h. Write limit h tends to 0. X is 1 plus h minus 5. That is x minus 5. So h is 0. Write here h value. So I got here 1 minus 4. Both are not equals to. Here LHL and RHL are not equals to. It's not continuous. LHL not equals to RHL. Next case 2. At x less than 1. So at x less than 1, what is the function? The function is x plus 5. At x less than 1, the function is x plus 5. So f of x is equals to x plus 5. So this is polynomial function. This is polynomial function. Therefore, f is continuous. Next, case 3. What is the case 3? X greater than 1. So case 3, at x greater than 1. When x is greater than 1, what is the function? X minus 5. So write f of x is equals to x minus 5. This is polynomial function. Therefore, f is continuous. Therefore, f is continuous. So at 3 cases, the first case it is not continuous. Why? Because we got different values. So first one is not continuous, second one is continuous, third one is continuous. How can we give the conclusion? So thus f is continuous for all x belongs to R except where it fails at x is equals to 1 case it fails. So except 1. So f is continuous for all real numbers except 1. I hope you are understanding. If you have any doubt, please comment. Okay, thank you for listening. We will discuss next problems tomorrow. Thank you.